guys know that an exponential, well, first of all, let me do this. Let's do this. Y equals 2 to the x. If I want you to find the inverse of that, what are the steps to doing that? Switch x and y. And then what do we do?
Solve
for y. And just so you know, when you have something like a variable in the exponent, you can't solve it until I teach you how it all connects with logs. But, so let's graph. What does the graph of 2 to the x look like? That's what it looks like. Now let me show you a couple of cool properties here connected with this whole graph. This is the graph of what? X equals 2. Nope. This is the other graph. This is the original graph. Y equals 2 to the x. Has a few properties here. We have an asymptote at y equals 0. You know that, right? Exponentials have that asymptote. It will always cross at the point 0, 1. How come? How come I can be assured that that will always cross at 0, 1?
0 power is 1.
Very good. Anything raised to the 0 power is 1. So if I put a 0 right here, it will be 1, right? Okay, so I know that it has an asymptote at y equals 0. I know that it will always cross at 0, 1. This graph happens to be increasing. Let's talk domain. What is the domain of this graph? All real numbers. And what is the range of this graph?
I think it's probably 0.
0 to infinity, right? Are we okay with that? All right. Now I cannot solve for y. I told you when it's in the exponent, I cannot solve for it right now with this stage of the game. But could I graph it?
Yeah.
Yeah. What does a logarithmic graph look like? You guys know this already. Do you have this domain and range if I erase it? I'm sorry that I'm having to work in such a small area. Is it pretty weird? I just write something and then erase it. Do you all have your domain and range?
Yep.
I just have to erase the domain
It's
and
the
range.
opposite way.
Are you okay? It's going. Okay, so a logarithmic graph, you guys know what it looks like. It looks something like, and I'm going to try to get this right, something like that, right?
Yes.
Is that symmetric around the line
Yeah.
x equals y?
Right.
So maybe logarithms are inverses of exponents?
Yeah.
They are. Now remember, an inverse is simply switching the domain and range. Okay, I've stated that a couple of times. So now that we have established that the logarithm is an inverse of an exponent, are you all okay with that idea? So let's see some properties here. With a logarithm, you guys know with a logarithm we have an asymptote at x equals 0. Cannot ever log a negative number. And if you don't believe me, try it in your calculator and say error. You just can't do it. Okay? This will always cross at
1, 0.
1, 0. This is increasing as well. What is my domain?
0 to 0.
0 to infinity. What is my range? All real numbers. Have I just switched my domain and my range?
Absolutely.
That is the definition of an inverse. You're just switching your domain and range. So do you see a small connection here? Okay. All right, so let's go back to that little thing I gave you that I just erased so I could do this graph. And I call it, once again, crossing the bridge. A to the y. That stands for if and only if in math language. All right, so if I'm trying to get from exponential to logarithmic, and this is why I'd say a log is an exponent. Can you see that this is an exponent right here?
Yep.
And when I convert that exponent to a log, the exponent is a logarithm. Now it's really funny because I have had so many people teach me that through my growing up years of math. A logarithm is an exponent. And I heard it and I could repeat it, but I was like, what? I don't get it. But it is. So I'll say it to you and you might be confused and someday it'll just hit you. I'll go, oh, I get it. Okay, all right. So let me show you kind of what we can do here. Let's take this original equation. This is in,
X.
let's go ahead and, I'm trying to decide. Let's do this one. X equals 2 to the y, and let's put it in logarithmic form. So I would then say, remember, whatever my exponent is, y equals log. Is this the base of the exponent?
It sure
It's
is.
the base of the log, too. Okay, so whatever the exponent is, you will say that exponent equals a log base, and then whatever the base is of the. Okay, if I were to put you at the board for the last 20 minutes, is this enough for you to convert back and forth from log to exponent? And then I want to show you one more example that I'm going to have you do at the board. We've got to take a single log and expand it, and we've got to take an expanded log and simplify it. So I'm going to show you that really quick. And then, give me 2 seconds. Let me see where I want you to be. Okay, go ahead. Go to the board, and then I will show you that in a minute.